What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to be discussing data, and this is an introduction to this topic. Good for you, we're not really looking at much maths today, but you have to be on top of the terminology in order to discuss data effectively. If you can't communicate using the same language, you're never going to get your point across. So the first thing we're going to look at today are things called variables, and this is what we're looking at specifically when we perform an experiment or a survey. A really good experiment is going to change one thing, and we're going to measure one thing at the exact same time. If you're changing heaps of stuff during an experiment, it no longer becomes valid. We want to see what the effect of one change will be on the outcome. Just have a look at those two words that I've used, record and manipulate. They're going to come back in a really important way in a second, but just make sure we know that we're manipulating one thing and we're recording the data of one thing, and that gives us a valid experiment. So there are two types of variables. The first one is what is called the dependent variable, and this is what we record. So this could be stuff like how long, how far, even how many people think this, and that always goes on the y-axis, so the one that's going up and down. This is incredibly important. If you get these mixed up, you lose a mark straight away in any test in maths and science. So it's a really good idea to get on top of this early, because then you don't have to work as hard in two subjects. If that one's called the dependent variable, the other one's called the independent variable. And the independent variable is what happens no matter what. And it always goes on the x-axis. This is the thing that we are manipulating in order for our experiment to work. So this could be who we ask. So if we ask year 8 students compared to year 10 students, we might get different answers, but we would ask them the same questions. We're keeping that the same. We're just manipulating who we are talking to. Other things that could matter is how long we measure for. If we're doing an experiment every day, that would be our independent variable. The time's going to happen anyway, we just happen to be looking at it. And this independent variable always goes on the x-axis. You will see time or age down there a lot in maths, but it doesn't have to be there. So just make sure we know what we are looking at. Dependent is what we record. Independent is what we change or manipulate. The way that I remember these two is that the dependent variable is what we record and goes on the y-axis. So I call that dry. And then we manipulate the independent value, and that goes on the x-axis. So I remember dry mix, and that's all I remember. These things are confusing, and students struggle with this all the way up into year 12. But just having a formula for remembering, okay, what do we change? What am I recording? Will help you kind of know what these questions are asking. So it's not just a 50-50 guess every single time. The second thing we've got to talk about are the types of data that we can get. The first type of data is categorical. These are groups of data. Anytime you're not getting a number as an answer, we are talking about categorical data. What's your favorite color? Who's your favorite sports team? Favorite band? These are all categories. If I asked you who's your favorite footy team and you said the third team, that wouldn't make any sense to me. If your answer is a word, we're talking about categorical data. So the second type is obviously numerical, and this is where numbers come in. There are actually two types of numerical data. The first one is called discrete, and this is where there are no in-betweens. We're dealing with 0, 1, 2, 3, no decimal points. So a really easy example of this is like in sports. In basketball, you score 2 points, you score 3 points. You never hit a shot and go, yep, that one was worth 1.7477 points. That doesn't make any sense. They are discrete jumps every single time in that score. The other type is continuous. This is where there is a continuous line of numbers and anything is possible during that data set. An example of this could be something like height. Usually we see this rounded to 2 decimal places or to inches, but that's more because of the equipment we're using. If you had an exact laser or something like that could tell us exactly to the nearest decimal place possible what your height would be, we would see that there would be really small differences between two people that were 170 centimeters. So this is a type of continuous data. The third thing we need to learn about is the people that we actually sample. There are two types. We've got a population, which is everyone included in that population, or we have a sample of the entire population. So we're just looking at a small section. The sample is really helpful for predicting things when we can't ask every single person, but the population data is going to be more accurate overall. One thing that you do have to be wary of is that the population could be the population in one example, or it could be a sample of another example. How does that happen? Let's think about if I took a sample of my class, my year 8 class, that would be an entire population sample because I'm asking every single person in the class. But then if we were looking at all of year 8's data and we said, oh, what's Jono's class like? You would then say that my class is a sample of the entire of year 8. So just making sure that we're on top of, hey, this could be both things is important when we're discussing data in a nuanced way. And just on this note, the bigger the sample or the sample size increasing makes our survey more accurate because it represents more of the population. If you ask one person how tall they were and they said, oh, I'm 190 centimeters, that doesn't mean everybody in the world is 190 centimeters. You need more to get a better perspective of what the average would be. So just making sure we know the bigger the sample size, the better the result. That is something that is important, especially in science. That's why we make you do more and more experiments instead of just doing the one. Finally, last one, I promise, we've got how we got the data. Primary data is collected by you as an individual. This is where you go out and ask questions and get an answer straight away. You're not taking it from everyone else. Secondary data is where you look at some statistics or a survey that someone else has done, and then you representing that then becomes secondary. So primary is first, like how you go to primary school first, and secondary is second. So here is a list of all the terms that we've learned today. I know it's a lot of information, but we've got really 4 categories. The first is our variables, independent and dependent. Then we're looking at the type of data we could have. Really, you just have to think of categories and numbers, all right? And then in numbers, there are discrete and continuous. We also have to know if it's a population or a sample, and I'm sure that'll make sense. Population is everyone in a certain group, and a sample is a section of that group. Finally, primary data is collected by you, and secondary data is collected by someone else, and then you interpret that information. Thanks so much for watching this lesson, guys. I know it's a little bit annoying going through all this maths when we're really not talking about numbers at all, but having a good understanding of this will make this topic make more sense as your teacher's explaining it. Thanks so much for watching, and I'll catch you later.